Okay, so that's how we do it. Okay, that's how we note down the positions, and that helps us. Okay, now exactly same nakshatra system, and I'm going to not take time to explain the zodiac, but the 12 zodiac system we can quickly superimpose on it. So the nakshatra I told you here was the Ardha and then Punarvasu. Those two nakshatras and half nakshatra portion of the other nakshatras, that is the area of the star sign, what we call zodiac Gemini. Okay, and I'm going to go quickly through these. Then if you go another 2.5 nakshatra like that, that will be Cancer. Okay, and then Leo, Virgo, Libra, Scorpio, Sagittarius, Capricornus, Aquarius, Pisces, Aries, and Taurus. Okay, so for example, those of you who may know, if this is Mrgashira, that behind that is the Rohini, and then this is a Kritika. If you look at the Taurus, the bull, okay, and the nakshatra Rohini is considered, if you look at the sky and if you look at some the Wikipedia maps, it says that Rohini, the red star, is the eye of that angry bull. Okay, that's how people visualize it. So it comes right there. So the same nakshatra system, if it is divided in a different fashion, it is visualized as made out of 12 things. Again, there is a reason why 12 and why 27. Okay, we will look at that in a minute. Okay, let's quickly look at the ecliptic. It's a geocentric perspective, which means we are as if looking from the Earth towards the sky. In reality, we do understand Sun is the center and so on. Okay, and this is also the astronomy software view. And I don't know if we will have a time today, but if we do, I will show you the astronomy software also. If not, some another chat session. Okay, all right. So Earth is at the center. We are looking at the sky where we can, and these stars don't move. Actually, they move. Remember, I told you at the beginning, everything is changing, everything is moving. But these background stars are moving so slow that they, some of them have not moved at all for the last 100,000 years. I mean, not at all in the sense, not something that matters to us for everyday purposes. That star is more or less in the same place. Okay, just like the tree in your yard, it hasn't moved unless you cut it. It's there for a few months or it's there for a few years and something like this. These stars are there in their positions for 100,000 plus years. Actually, after that, they do change. Okay, and that also helps us know the antiquity of our civilization. Okay, or some of the changes. So we're looking from the center of Earth at the center, looking at the sky. And if you notice the path of the sun, like where the sun is rising and how it is going up in the sky and then it's setting, and it's not always the constant, as you know that, and that is because the Earth's axis, right? Because Earth is rotating around the sun. But whatever we can trace as the path of the sun in the sky is called the ecliptic. Okay, that green line that I have done, and that is the reference frame for we all Earthlings to study our astronomy. Remember, I said that's the reference you must understand. So, what is ecliptic? If I had a quiz, at the end of it, then this would have been definitely a question. What is ecliptic? And the answer is it is the reference for astronomy, and in fact, it is the path of the sun in the sky with respect to the Earth. Okay, so that's the reference point based on which we do everything else. And why is that? So now that's where the sun is going to be. But why is that important? It so happens, I will not go into why that is so, that all the visible planets, including the moon, okay, they are seen in the sky more or less along the ecliptic, not exactly on the ecliptic, but more or less along the ecliptic. And if you observe this for a long period of time, sometimes you will see these on the left side of the ecliptic and sometimes on the right side of the ecliptic. But on an average, they are along the ecliptic, okay, with some exceptions, like Pluto is kind of the last one there, here, it's kind of a bit weird orbit it has. I've not shown that, but they go along the ecliptic. And what's the great benefit of it? We can use the same nakshatra system or same zodiac system to track not only sun, not only moon, but we can also talk about the position of all the planets, including moon, including sun, using that same nakshatra system. It's a very, very efficient tool for us. All right. Now, position of the moon as seen from the Earth. Now, what we're going to look at is the lunar months. Okay. So lunar months. Okay, there are two types of lunar months. Okay, I don't know if you knew that. If not, today you're going to, there's something, the kids, you'll be able to go back to school and talk about it. And some of you might have actually already studied in the class, at least here I know my daughter, I forgot now which grade, but she got to study the sidereal and synodic moon, lunar months. So maybe you have studied those two. Again, we are looking from the Earth. So Earth is at the center. That is the only reason Earth is at the center. We have got the nakshatra system. Now we got the ecliptic, the reference grid, the path of the sun. And now we are going to take the moon around the Earth through 30 days, through one lunar month. Okay, so what I'm showing you at nakshatra number 27 here, and please pay attention, okay, to understand the difference between the sidereal and synodic lunar month. It will also explain you why our ancient astronomers selected 27 nakshatras, or they divided the sky into 27 or 28. You will also understand just a few minutes why they divided into 12, like zodiac. Okay, so what I'm showing you right now is like, do you see the moon? Not really. All you see is a dark square, because that's like Amavasya, which means the sun is very much near the moon. So if seen from the Earth, you would see the sun and moon more or less in the same position, in the same nakshatra, like number 27. Okay, so we're starting with Amavasya. A lunar month that begins with the Amavasya and ends with Amavasya is called Amanta lunar month, or Amanta Chandra Mas. Mas is for a month, Chandra is for the moon, and Amanta meaning Amavasya to Amavasya. Okay, the dark day to dark day, or new moon day to new moon day. There is another system in India also prevalent. It's called Purnamanta, and I'll explain that in a simple way. It starts with the full moon. They start counting the month, the first day, with the full moon day, and they end with another next full moon day. Okay, we will stick with the Amanta for the rest of the discussion. So this is our Amavasya. Okay, so that's day one. Now we are going to start counting. Okay, the next day it will be Pratipada. Okay, the first day of the first fortnight. Then Dvitiya simply means two. Tritiya means three. Okay, Chaturthi, like a Ganesh Chaturthi yesterday. And if you would have observed in the sky, you would have seen a crescent moon like that, So that's Chaturthi. Panchami, Shashti, that's 6. Saptami, 7. Ashtami, 8. Navami, 9. Dashami, like a deka, okay, that's like a 10. That should tell you where all the numbers that you use in the school, where they came from. They came from India. That's why those names are like that, okay. All right, and we continue, okay. Ekadashi, Dwadashi, Trayodashi, Chaturdashi, and Purnima. Purnima is the full moon day, okay. So the first fortnight, the first half called Paksha, Shukla Paksha, is over now, okay. So notice what happened, okay. So we have gone through those days. Now we got the full moon day around 14, 15 day, okay. We are not going to look at the variations of the moon right now. Then just let's continue. So now the second half began. It's called a Vadya Paksha or a Krishna Paksha. Like this one is like a waxing moon phases, and then now you're going to look at the waning moon phases. In the Indian system, those are Vadya Paksha or Krishna Paksha. Okay. So 16, that will be again called Pratipada, the first day of the second half. Dvitiya, the names are same, but now we are calling it Vadya Paksha. Tritiya, Chaturthi, Panchami, Shashti, Saptami, Ashtami, Navami, Dashami, and so on. But I want to stop here. So I started from this point, the first 27 nakshatra, and when I went through the whole phases of the moon until moon came to the exactly same nakshatra, that is what? One complete cycle of the moon, right? That is one full revolution of the moon around the earth, and it takes 27.322 days on an average. And that is the reason why our ancient astronomers conceived 27 goalposts or 27 milestones, because they can track a one complete rotation of the moon. Okay, this is called by the way sidereal. The sidereal comes from a star. The sidereal means a star. With reference to a star, in this case nakshatra is nothing but a star, reference star. The moon completes one rotation on an average 27 days. Therefore, 27 nakshatra. And the lunar month is called sidereal lunar month. Okay, but something else has happened. See, we started with Amavasya, the totally dark day. Okay, new moon day, and there is still a phase left. It's not complete yet. So if you want to go to the phase, so that the phase also matches, like full moon to full moon or Amavasya to Amavasya, we have to go additional 2.5 days, close to get that 30 days. That's why we have 30 days in a lunar month, okay? And then people also envision that for the solar month. We'll get to that in a minute. Okay, so that additional time is required for the moon to come into the same phase, like the same as a full moon or same as Amavasya. And that average time that's required is 29.53 days. For practical purposes, we round it off to 30 days. And that's why our lunar month is approximately about 30 days. Okay, so the second month is the synodic lunar month, okay, which is like same phase to same phase. The first one, sidereal lunar month, is from same star again to same star. So these are two different months, okay. And why does it take that longer for the moon to come into the same phase? Okay, again, if it was open, I would have asked you that as a question, and I would have waited for the answer, but I'm going to give you the answer. Because remember, while this moon is going around the earth itself is moving with respect to the sun, okay? And I'm going to show you if this works. If it doesn't work, we will move on. I'm going to show you a quick demonstration of that, okay? So let's see what works. Okay, I think it might work. Okay, so it begins. Okay, so notice what you're seeing here is the sun. This is our earth, and this is the path of the moon. So moon is going around, okay? So see, this is when the day of Amavasya or new moon, okay? So sun and moon are at the same point as seen from the earth. And now we go through another rotation. Now notice what happened. Okay, this is like equivalent to 27 days. Okay, so moon exactly came into the same position with respect to nakshatra, but not with respect to the phase and the position of the sun. So it has to go through that additional point. Okay. Yeah, so that additional distance is why it takes, instead of 27 days, it takes like 30 days. Okay, because now it is the same phase. Okay, everyone understands? I hope they do. So let's see. Okay. Yeah, I hope that was useful. Okay, let's go quickly. I'll go a few more minutes and we'll stop. 27 nakshatras and position of the sun. We are quickly going to look at something called cardinal points and equinoxes. Okay, again, sun at the center. And now remember what I have changed. So far I showed you earth at the center, and now I'm showing you sun at the center. Okay, I'll bring you back again to earth at the center. I say one of the requirements for understanding astronomy is the ability to easily move from sun at the center to earth at the center without getting confused. Okay, that's very important. So you have to practice that. Okay, so sun at the center. This is our earth. I showed this similar position at the beginning of our presentation. This is the north hemisphere. Okay, so northern portion is closer to the sun, which means what? We have a summer, like a 21st June. Okay, the most northernmost point when we get, and again, this is my reference nakshatra system. The most northernmost point is what? In our calendar, current days is 21st June. We call this is the day of summer solstice. Okay. And if you want to know when does the summer solstice happen, we know it is 21st June. But if you want to know the nakshatra, okay, what we do, remember, we draw a line through the sun and note down the nakshatra. That nakshatra is going to come out as what? Mruga nakshatra. I don't know if you're familiar, but in India, for example, when the sowing of the seeds just before the monsoon, that begins, they will say, okay, oh, it's a Mruga nakshatra. It's time to sow the seeds. Okay, for agriculture that is based on monsoon. Well, they are saying it's a Mruga nakshatra. They are referring to Mruga nakshatra in the sense of the sun is in the Mruga nakshatra. Okay, that is this portion, because that happens around 21st June. Okay, now if you go around, the earth is moving. Now it takes a position. Now the September comes. Very soon we will have September, 1 month from today. Okay, and that's the autumnal equinox. If you want to know the position of the sun, you draw a line and note down the position of the sun with respect to nakshatra in the background nakshatra. If you go to 21st December, okay, now if you want to know the position, now look, northern hemisphere is away, so to say, from the sun. That's why we have winter in northern hemisphere. And if you want to know the position of the sun, you're going to draw an imaginary line and note down the nakshatra. It will be between Mula and Purvashada. So that is the nakshatra of the sun around the 21st December. And same thing for spring equinox, okay, and so on. Now the position of the sun as seen from the earth, you know that there are 12 months that we refer to. Now remember what I did. I brought the earth back to the center. As I said, it's very important that you become very comfortable with sun at the center, earth at the center, easily able to replace it and still not get confused. Okay. So now if I want to know which nakshatra the sun is in, well, that's simple. If earth is at the center, all I need to do is look at the sun. Okay, again, it's going to be here. That's how I've drawn it. Okay, it will be near Mruga, 21st June. Same thing, different nakshatra for 23rd September, again for 21st December, and then 23rd March. These are called cardinal points. And the Gregorian calendar that we use is matched to these cardinal points. Okay, so if there is a correction that they need to make, they will make it in such a way that the 23rd March will match with the spring equinox, 23rd September will match with autumnal equinox, and so on and so forth. That's how it has been designed in 1582. Okay, using Indian mathematics, because until then they were so confused, you won't imagine. Okay, there was a gap of 44 days and 88 days between what was actually happening versus what their calendar was. Okay, all right, that's a totally different story. All right, so now we know that there are 12 more solar months. Okay, and that's why these are 12 months. Now, because the whole year 360 degrees, or approximately the sun going around the earth or going around the sun, whichever you want to look at it, it happens what in approximately 365 days. But if they complete that circle in the circle is 360 degrees. So somebody decided to divide as a simple approximation 30 degrees each. So 12 times 30 is 360, and therefore we have 12 zodiac. So we can say just like the nakshatra, oh, moon is in this nakshatra, moon is in Chitra today, or Hasta tomorrow, or whatnot. Now we can talk about moon is in Gemini, moon is in Cancer, sorry, sun is in Gemini, sun is in Cancer, sun is in so and so zodiac, and that's why there are 12 zodiac. Okay, so there's a reason, there's a logic, method to madness. Why 27 nakshatra and why 12 zodiac? Okay, quickly, the sidereal, just like we have sidereal lunar month and sidereal lunar, the synodic lunar month, we have sidereal solar year and sidereal and synodic solar year. Okay, so what happens if we start on this day, the spring equinox, 23rd of March, and we come completely, make one full circle and come back? The time required to achieve that is one type of year. Okay, that's a tropical solar year, from one spring equinox to next spring equinox. Okay, and that takes on an average 365.242 days. But what happens with respect to the background star, background nakshatra, it exactly doesn't come in the same time. It takes 20 additional minutes, because it's only 20 minutes. We don't notice it in the short term, but in the long term, it has huge implications. Okay, and when you look at the sun to leave and come back to exactly the same position with respect to the star as seen from the earth, it requires 20 additional minutes every year, and that's the sidereal solar year. And just from spring equinox to spring equinox, that tropical solar year takes 20 minutes less. Okay, and this is the basis for what we call precession of equinoxes. I'll go a bit fast to this. Now, in the Gregorian calendar, we are using this January, February, and I'm not going to that. You may know how this name came into being. For example, there is evidence that March used to be one, like March, start marching, like start, go, March. That's how that number one, first month came into being there. March used to be first month by day. And if you don't believe me, just stay with me and you'll see that. For example, after August, what happens? August is after August, the king, right? And the same thing with the July, the Julius Caesar. Everybody wanted their name to the given to the month. But after that, they kind of lost interest, maybe. I'm just saying it humorously. But come to September. And now what do you see, guys? Do you notice something? September 7, October 8, November 9, December, Deka, Dasham, 10. So from March is the 1. Actually, that's how the calendar was. And they had a calendar of 10 months. That's another complex subject we'll not go into. That ended in December as a 10. Okay, so 7, 8, 9, 10 is still preserved into the Western calendar names, but the other names were destroyed with the names of the kings and whatnot. And then, so when Augustine had the 31, then the Julius Caesar also wanted 31. So he was also, you take 31, but it has to come up from somewhere. So the poor February, they took the number from February, so February became 28. One gone and another gone, and so on and so forth. That's a long story. But in the Indian system, actually there are Taittiriya Samhita, which is part of Yajurveda, we have the names of the solar months. Okay, very, very perfectly matched with the seasons. The Madhu and Madhava is Vasanta Rutu, Shukra and Shachi is a Grishma Rutu, Nabha and Nabhas, like I'm here, is a Varsha Rutu, Isha Urja is a Sharad Rutu, Sahasya is the Hemant Rutu, and Tapasya is the Shishira Rutu. And it's there, but it was completely lost, completely almost forgotten for various reasons. We'll not go into that. And that is something we have re-established with this Bharat Dindarshika. Something interesting I want to tell you. These months, actually, we can count the true length of the solar months. I'm going to show you, for example, in our times, the length of the solar months more or less is going to be like this. Madhava, the month of Madhava would have 30 days, month of Shukra would have 31 days, month of Shuchi would have 31 days. Now, this is a surprise to you, surprise to many. The month of Nabha in our times will have 32 days. Now, you have never heard of a solar month of 32 days. In fact, you have not heard of any month of 32 days. Nabasya 31, and I'm just going to complete this quickly. And Tapa, we have 29 days. Now, how do we figure this out? Remember, 360 degrees, we are dividing them into 12 parts. So each month is 30 degrees. We are actually calculating the time taken by the sun, starting from that point there, which is the spring equinox, the point of Madhava here, beginning of Madhava. When it goes to 30 degrees, we say Madhava, month of Madhava is over. Now, it may take 29 days to do that. It may take 30 days to do that. It may take 31 or it may take 32. So the length of the solar months that you're seeing here are actually true astronomical lengths for these solar months. Now, why number takes 32 and why Tapa takes 29? That's a different subject. I'm going to give you a homework, okay, to work on that. Like when sun goes fast and when sun goes slow, okay? Something to do with that. All right. I'm almost done. A cycle of the precession of the Earth's axis. I'll just introduce that, and then we will get into question answer, and then I'll show you something if we have time. Okay. So celestial phenomena. Now let's understand what is the precession of equinoxes. Okay, and we'll stop there. So this is our 21st century. This is our Earth. Now remember, Earth is inclined at an axis, 23.4 degrees or 5 degrees. Earth is rotating around itself. Okay, but it's also inclined at an angle, and that's why we get the seasons as it goes around the sun. Now, when Earth is inclined, if you look at this axis, an imaginary line, you stretch it into the sky, and you try to look at the area of the sky that is called NCP, North Celestial Pole. It's a point, it's an imaginary point. And if there happens to be a bright star next to it, we call it a pole star. In our times, that pole star goes by the name Polaris. Okay, that's Polaris. But that Earth's axis also has another interesting moment. We don't observe it because it's very, very slow. In fact, it's like the top, the top of the top. It has this motion, but it's such a slow motion that to complete one cycle, it takes 26,000 years. Which means if we go back, let's say, by half of this 26,000, say 30,000 years ago, remember that 28th nakshatra that I referred to and say forget about it, Brahmā Rashi, Abhijit, Vega. It would so happen that that particular star becomes our pole star. Okay, so if we go back by approximately 13,000 years, the Polaris, what we see today as the pole star, was not the pole star in the northern hemisphere. It was something else. It was Brahmā Rashi or Vega, and you can see that the summer triangle. Those of you in astronomy, summer triangle, one of the stars is a Vega. And what is interesting is Ramayana refers to that star. Ramayana saying, at the time of Ramayana, that Brahmā Rashi, Abhijit, Vega was the pole star. The Ramayana verse says Brahmā Rashi, Vishuddhasya, Shuddhasya Paramarshaya, Archishmanta, Prakashante, Dhruvam Sarve Pradakshina. It's a Dhruva pole star, and the Saptashis, the big bear, the 7 stars of the panhandle are going around that Brahmā Rashi. And that is one of the 600 plus references that I used to determine the timing of Ramayana. But this was one of the very strong reference. Okay, so I'm going to show you going back like 14,000 years, 13,000 years. See, the Earth's axis that time would have pointed not to Polaris as it points now, but it would have pointed towards that Brahmā Rashi. That's what I mean by Earth's axis going like this. That is not to be confused with Earth's inclination, not to be confused with Earth rotating around itself, not to be confused with Earth rotating around the sun. Those are different motions. This is one additional motion. By the way, there are some additional interesting motions that we will not go into that, but I will give you a homework to look into this. Now, what is the consequence of this? Which means what? The pole star changes, right? Pole star changes, and we can see that here. I'm going to show you in 3 minutes. I'll stop. So right now in 2000 or 21st century, this is Polaris. If you can see my cursor, this is Polaris. Okay, this is called Dyumatsena. It kind of looks like a fish and a tail, and this is the tail of that fish, Dyumatsena. This is our Dhruva star. Okay, but let's go back in time. So if you go back in time, for example, to 3,000 years, okay, sorry, 3,000 BC, I mean, so go to like 5,000 years, okay. So this is 0, this is 2,000, this is 4,000, and now this is like approximately 5,000 years before our time, so 3,000 BC. This star that you see here, this star here, okay, this is called Draco. Some of you may know this constellation, Draco or Shishumar, and it is the star, the 14th star in the tail. This is the name of this star is Thuban. And our Indian ancient narratives have so many descriptions of Thuban. You don't call it Thuban, of course. They call it the 14th star of the Shishumar as the pole star. So we're talking of the time 3000 BC. Okay, so that time not Polaris, but this Thuban was a pole star. But let me quickly walk you all the way back 10,000 and even further, 12,000, the one I just showed you. This is the northern hemisphere. This is an inner polar region. This is the brightest star. This is our Brahmā Rashi. This is our Abhijit. This is the Vega. So if you go back 10,000 and further 2,000, so minus so 12,000 BC, this is basically the pole star. And in future, like in 14,000 years, right? So 2,000 more years, we will have this again as a pole star. So what I just showed you is the northern hemisphere. This is how the stars can be seen. Okay, let me see. Okay, and then I'll stop here. Now this is one thing I told you. The precession of equinoxes. What does it do? It changes the pole star. That's what I showed you, right? So this is for the northern hemisphere. You can also see same thing happening for the southern hemisphere. Let me take one more minute. In the southern hemisphere, if you go to Australia or Chile or Argentina, okay, South Africa, and if you're watching from there, what you're going to see right now, this is 21st century or 2000, they don't have a distinct star at the point of the south celestial pole. So yes, you can see Earth is rotating around some point, but there is no distinct star there. But that was not always the case. Now notice what happens if we go back in time, but because we are doing that for the southern hemisphere, we are not going this way. We are not going clockwise. We are going anti-clockwise now. Okay, it's the other hemisphere. So if you go back like a 3000, you'll find some star. But let me quickly bring it back all the way to that 12,000 BC, just like I did for Brahmā Rashi. And lo and behold, what you see, a very bright star This is the star of Agastya, sage Agastya, or also in Western astronomy called Canopus. So if you go back to 12,000 BC, which is 14,000 years ago, our Earth, on both sides when you look at it, had brightest pole stars. In the north, the Vega or Brahma Rashi; in the south, Agastya or Canopus. But I want to tell you something interesting, and I want to stop on that point. This particular instance of having two brightest pole stars on two sides for our Earth is noted down with very powerful, impeccable evidence in our Surya Siddhanta. Okay, and that was my paper that I presented at Oxford a couple of years ago. Okay, so with that, I'm going to actually stop here. I'll stop sharing also, and then see where we go